Hello everyone, today we are going to discuss about the artificial neural network. Let's start with the introduction. Artificial neural network or ANN is an information processing paradigm that is inspired by the way the biological nervous system such as the brain processes the information. It is composed of large number of highly interconnected processing elements like neurons working in unison to solve a specific problem. The artificial neural network are inspired by the information processing models like a brain. The human brain consists of billions of neurons that link with one another in some pattern. Each neuron receives the information from many other neurons, process it, and it is going to pass that processed input to the other neurons. ANN are very versatile systems like brain. How the brain is going to do the multiple works, in the same way ANN is also going to work. They can be used for pattern recognition and predictions, classification, regression, clustering, association and optimization activities. They can also be used in finance, marketing, manufacturing, operations, information system applications. ANN are composed of large number of highly interconnected processing elements called a neuron. This ANN is composed of a large number of highly connected processing elements like a neurons working in multi-layered structure that receives the input and it is going to process it and it is going to produce the output. ANN is designed for a specific application such as a pattern recognition or a data classification and are trained through the learning process. ANN makes a synaptic connection with each learning instances. ANN are like a black box trained into solving a particular types of problems and they can develop high predictive powers. Their intermediate synaptic parameter values evolve as the system obtains feedback on its predictions. Thus the ANN learns from the more training data sets. See, like brain, how that synaptic connection will be connected. In the same way, for each learning data set, the connection will be made for the parameters. If whatever the prediction is correct, then the parameters are going to be fixed. If the prediction is wrong, then we are going to be changing those parameters again and again. Next is the business applications of an ANN. ANN are used for the stock price prediction where the rules of the game are extremely complicated and a lot of data values need to be processed very quickly. See, in the stock price prediction, every second the value of the stock prices will be increasing or it may be decreasing. For predicting that one, it is very difficult. See, you cannot predict that one. It may be extremely high, it may be extremely low. You cannot predict on the some conditions or only few parameters if you are considering on that one. If you can predict, that is not possible in the stock price. For like this complicated problems, we are going to use the ANN. It is going to just think like a human and it is going to predict the things. Character recognition. See here, some people will be writing in the forward slanting, backward slanting. Like this, the people will be writing, and handwritten text will be. So some people will be writing individual words. Some will be writing in the cursive letters. So it is very difficult for the system to recognize. Using the ANN, it can be done. Recognizing the fingerprints. Traditional classification problems like proving a financial loan application. For these things, we can use the ANN. Design principles of an artificial neural network. Artificial neural network is as shown here in this figure. It will be like this. It is a single stage computational unit used for simple tasks. Here this x1, x2, x3 are going to become an input, w1, w2, w3, w4 are the weights, and y is an output. Here it will be our neuron. A neuron is a basic processing unit of the network. Neuron receives the inputs from the preceding neuron, does some non-linear weighted computations on the basis of those inputs, then transform the result into the output value. Then that passes the output to the next neuron in the network. The neural network should have at least one input, one processing element, and one output. See, the neural network is a multi-layered model. If it is a multi-layered model, it is going to have the multiple processing elements in the sequence. The sequence is going to be depending on the complexity of the predictive action. This piece here, the neurons, we have shown these neurons. The neurons may be in parallel or it may be in the sequence. Here, this and this are in the sequence. This and this are in the parallel. Based on the problems, we are going to keep this one here. The processing logic of each neuron may assign different weights to the various incoming input stream. Here, for each input stream, we are going to assign the weights. The weights is a non-linear function. Processing logic may also use the non-linear transformations such as sigmoid function from the processed values to the output value. This processing logic and the intermediate weights and processing informations are just what work for the system as a whole in its objective of solving a problem collectively. Thus, neural networks are considered to be an opaque and black box system. See here, this transformation functions, this weight and the processing element all together work, and they are going to be work together to solve the problems. How they will work, we are not knowing that one. Because of that, we are going to call this system as a black box system. A neural network can be trained by making a similar decisions over and over again with many training cases. It will continue to learn by adjusting its internal computations and communication based on feedback about its previous decisions. Thus, the neural network become better at making a decision as they handle more and more decisions. Based on the more and more decisions, we can improve the artificial neural network. Next is a representation of a artificial neural network. Here, a neural network is a series of neurons that receives the input. See, x1, x2, these are the inputs. Input from the other neurons, they are, and also it is going to have the weighted sums for each input. Using a different input for each one. The weighted sum is then transformed into an output value using some transformation function. Learning in ANN occurs when the various processing elements in the neural network adjust the underlying relationship. Based on the relationship of an input and output in response to the feedback on their predictions. If the prediction made was correct, then we are going to fix this weight and this inputs. If the prediction is wrong, then we are going to change the parameters. These parameter values, the weights and the inputs, and we are going to try to predict the correct output. Here, this transformation function, it is going to be depending on the tasks or a problem. It is ANN is usually using the non-linear sigmoid function. If the normalized computed value is less than some value, then the output value will be 0. If the computed value is at the cutoff threshold, then the output value will be 1. If this transformation function is a sigmoid function. If the transformation function is a nonlinear hyperbolic function, then the output will be either -1 or a 1. This based on the transformation function, the value will be changing, output value will be changing. See, a neural network, it is going to have every processing element in a different formats. Every processing element can potentially have a different number of input values, a different set of weights for those inputs, and a different transformation functions, and it is going to have some outputs based on the inputs. If the inputs and the weights are correct, then we are going to get the desired output. This is the representation of the neural network. Next is architecting a neural network. The most popular architecture is a feed-forward multi-layered perceptron with a backpropagation learning algorithm. There are multiple layers of P's in the system, and the output of neurons are fed forward to the P's in the next layer, and the feedback on the prediction is fed back into the neural network for learning. See, some of the architectures of the ANN we are going to discuss with some applications. Applications are classification, regression, clustering, association rule mining. For this classification, feed-forward network, radial basis function, probabilistic functions, regression feed-forward network, radial base functions, clustering, adaptive resonance theory, self-organizing maps, association rule mining, Hopf-field networks. These are the architecture we are going to use for these applications. Developing an ANN. How to develop an ANN? First work is to gather the data. First work you have to gather the input training data. Then you have to divide the data into the training data and the test data. Once again, we have to divide the training data into a training data and some validation data. This division you have to done. After doing this one, you have to do the selection of the network architecture, such as a feed-forward network. Like this, you have to select the architecture, then select the algorithm, then you have to select the parameters of a network. After doing this one, you have to train the ANN with the training data sets. After training the ANN, you have to validate the model with the validation data. After validation, if your output is correct, you have to freeze the weights and other parameters. Then you have to test the trained network with the test data. If whatever the trained data, the output is correct, then you have to deploy the ANN when it achieves the good predictive accuracy. If the predictive accuracy is correct, then you can use this ANN. Next is the advantages of an ANN. ANN imposes very little restrictions on their uses. ANN can deal with a highly non-linear relationship on their own. Without much work from the user or analyst, it is going to be working. They can help in finding practical data-driven solutions. This ANN is no need of programming. No need of programming anything. It only requires the training data sets. If the better the training data set and better the results. No need of any programming efforts here. It can handle the variety of problem types, including classification, clustering, associations. It can tolerate if the data quality is poor data quality. They do not restrict the data to follow strict normality and or independence assumptions. They can handle both the numerical as well as the categorical variables. ANN can be much better than other techniques. They are going to be used to provide the better results compared to the statistical counterparts. Disadvantages of ANN. They can be deemed to be black box solutions, lacking in explainability. Optimal design of ANN is still an art. It requires the expertise and expensive experiments. It could be difficult to handle a large number of variables. If the number of variables are large, it is very difficult to handle that one. It takes a large data set to train an ANN. If the data set is large, it's very difficult for training. These are some disadvantages. This completes your ANN. If you are having any doubts, you can ask me in the comment section. We'll stop here.